right, we're going to begin our review of Chapter 10, Section 2, Chapter 10, Section 2. And as you can see, the learning target for today is to graph quadratic equations. Well, the first thing we need to do is, of course, define quadratic equation. A quadratic equation is a function which is greatest power is of the variable is 2. So it's going to have an x and a y, and it's going to have the greatest power of that x as being the value 2. Let me erase this work so we can start over. And let's calculate some values of x and y. Here I'm going to calculate values and that corresponding value of y. If I give negative or x to be just some sample points, -1, -2, 0, 1, and 2. And I calculate the value of y by plugging each of these into the equation. -2 squared, of course, is 4. 4 times 5 is 20. -1 squared is 1 times 5 is 5. 0 squared is 0 times 5 is 0. 1 squared is 1 times 5 is 5. And 2 squared, positive 2 squared, is 4 times 5 is 20. So if I look to graph these ordered pairs, and I'm just going to write them up here so I can see them when we roll the screen up. It's -2, 20. And the second one is -1, 5. And the third one is 0, 0. The fourth is 1, 5. And the last one is 2, 20. I could pick other ones and do more, but I think this will give me the general shape. So as I look at this graph, I'm going to choose to let my x-axis be -1, -2, -3, -4, and of course 0, and then 1, 2, 3, and 4. And as I go up the y-axis, I'm going to let each one of these be, I think, 5. So that'd be 5, 10, 15, and 20. All right, so now let's graph our first order pair, which is -2, which would be over here from 1 to 2 and up to +20, would be right there. The next one would be -1 and 5, which would be about right there. The next one would be 0, 0, about right there. 1 and 5, and 2 and 20. So if I connect this graph with a smooth line, it would look something like that. And of course, it would continue on in both directions. All right, so that would be the graph of y is equal to 5x squared. All right, let's look at the next one here. Clear off this work. And graph of y is equal to -4 times x squared. Again, I'm going to pick some values of x, calculate the values of y, see what they work out to be. I'm going to pick some easier ones. I'm going to pick -2, -1, 0, 1, and 2. Those 4 points should give me a good estimate of the way this is going to look. I got a -2 squared is 4. 4 times a -4 would be a -16. -1 squared is 1 times -4 would be -4. 0 squared is 0. 0 squared is 0 times 4, which would be -4, which would be 0. 1 squared would be 1 times -4 would be -4. And 2 squared would be 4 times a -4, which would be -16. So the ordered pairs in this case are -2, -16, -1, -4, 0, 0, 1, -4, and 2, -16. So as I look at my graph here, I'm going to let the values going across on my x-axis. I'm going to let this be -1, this be -2, -3, and -4. And this, of course, be +1, +2, +3, +4. I think as I go down, though, I need to increase my graph to make sure that they are the scale factor to make sure that they fit. So I'm going to go here 2, -2, -4, -6, -8, -10, -12. This would be 12, -12, -14, And if there's one more here, yeah, negative 16 would be at the bottom. So negative 2, 1, 1, 2, and then down to negative 16 would be right here. The next one, negative 1, negative 4. Negative 1, negative 4 would be right here. Then 0, 0 would be right there. 1, negative 4 would be right here. 2, 1, 2, down to negative 16 would be right here. And again, if I connect the graph with kind of a smooth approximation here, that's the way my graph is going to look for this equation. All right. Let's look at this next system here. Let me get rid of this work. All right, we've got y is equal to negative 3x squared. As I look at this, I can see a couple of things about it. The negative sign here is going to indicate something to me. As I look at it, I can see that I know the graph is going to open downward. The graph is going to open up downward, so it cannot be answer A, it cannot be answer C. So it's either got to be B or D. Let's check and find out which one. So I'm going to again choose some values of x, calculate the values of y, and see which makes sense. Negative 2, negative 1, 0, 1, and 2 seem to work. So negative 2 squared, negative 2 squared. Negative 2 squared would be 4. 4 times negative 3 would be negative 12. And negative 1 squared is 1 times negative 3 would be negative 3. 0 squared would be 0 times 3, which times negative 3 would be 0. And 1 squared would be 1 times negative 3 would be negative 3. And of course, 2 squared would be 4. 4 times negative 3 is negative 12. So the ordered pairs I've got are negative 2 comma negative 12, negative 1 comma negative 3, 0, 0, and 1 comma negative 3, 2 comma negative 12. All right, as I look at these two graphs that they propose as answers, I'm going to check this one right here at the origin, 0, 0. If I look at 0, 0, that's right here. The graph that they have under B doesn't go through that point, so it cannot be answer B. It must be answer D. And so answer D is the correct answer. If I look at this graph, we're going to graph 3x squared plus 1, 3x squared plus 1. Again, I'm going to pick some values of x and y, and I'm going to calculate, I'm going to pick some values of x and calculate values of y. So I'm going to look at negative 2, negative 1, 0, 1, and 2 as 4 values of x. And I'm going to calculate values of y to see which ones, and then I'll graph those. So as I look at this here, negative 2 squared is 4. 4 times 3 is 12, plus 1 is 13. It's positive 13. Negative 1 squared is 1, times 3 is 3, plus 1 is 4. 0 squared is 0. 0 times 3 is 0, plus 1 would be 1. 1 squared, positive 1 squared is 1, times 3 is 3, plus 1 is 4. And 2 squared would be 4, times 3 would be 12, plus 1 would be 13. So let's look at setting up our x and y axes here. All right, so I'm going to let my ordered pairs go across as I look at x and y. X's, I need to go probably a value of 1, negative 1, a value of negative 2, negative 3, and so on. Positive 1, positive 2, positive 3. And as I look for my others, I've got to get as high as about 13. I'm going to count by 2's again. So this would be 2, 4, 6, 8, 10, 12, and 14. So as I graph, my first ordered pair was negative 2, 13, negative 1, negative 2, and up to 13 would be about right here. And then the next ordered pair was negative 1, 4, negative 1, and up to 4 would be about right here. Then 0 and 1, 0 and 1 would be about right here. 1 and 4, 2 and 13, I think, was the answer, 2 and 13. So as I graph these and I complete them, and I got off a little bit on the graph, but notice that graph does not go through the origin. It goes to the point 1, 0, 1, 0, 1. All right, let's look at number 7 here. Graph y is equal to 2x squared plus 2, 2x squared plus 2. As I look at this, since this is a positive sign, I know that it's going to open up, and I know that it's going to cross the origin or the x-axis. It's going to cross the y-axis at positive 2. Well, if it's going to open up, it's obviously not B, and it's obviously not D. And as I look at this, these two graphs, I have to decide which one of these. Well, let's find some ordered pairs between A and C that are going to work here. I'm going to go -2, -1, -0, 1, and 2. Calculating, if I put -2 in squared would be 4. 4 times 2 would be 8. So this would become 10. If I put in 1, 1 squared would be 1, times 2 would be 2, plus 2 would be 4. 0. 0 squared is 0, times 2 is 0, plus 2 would be 2. 1. 1 squared would be 1, times 2 would be 2, plus 2 would be 4. And if I figure out the 2, it would come out to be 10. 2 squared is 4, times 2 would be 8, plus 2 would be 10. So if I look at these here, and I call this is 0, 0, this would be 1, or -1, this would be -2, +1, +2. And if I go 2, 4, okay, if each of these is 2, so this would be 2, 4, 6, 8, and 10. It does look like at -2, 1, 2, and 10, that doesn't get there. If it goes -1 and -1 would be 4, which would be right here. Okay. Well, if each of these units was 1, though, if this was 1, 2, 3, 4, 5, and so on, -1 and 4, 1, 2, 3, 4 would be right here. That looks like it checks. 0 and 2 checks. 1 and 4 checks. Could easily be A. If this is counting as 2's down here, we could go 2, 4, 6, 8, 10, and it doesn't hit at the 2, so it cannot be C. A is my correct answer. A is the correct answer. Got another one to do here where we're going to graph y is equal to a -x squared minus 2. Again, I pick values of x, calculate the values of y. -2, -1, 0, 1, and 2. -2 squared is 4 minus 4 would be a -4, minus 2 would be a -6. -1 would be 1, but then -1, because of this negative sign, -2 would be -3. 0 would be -2. 1 would be -1 minus 2 would be -3. And -6 would be my ordered pairs. If I look to graph this, I'm going to let this be -1, -2, -3, and so on. This be +1, +2, +3. And as I go down, we're going to go -1, -2, -3, -4, -5, and -6. All right, so the first one here is -2, -6. -2, -6 would be right here. The next ordered pair is -1, -3, which would be right here. The next ordered pair is 0 and -2, which would be right here. Then 1 and -3, and 2 and -6. So this would go a curve kind of like this. I missed there a little bit. Okay. Well, let's look at this one. Negative 2x 2x squared minus 1. First of all, I can tell that it opens down, so it cannot be B, cannot be C. And I can see because of the minus 1, it does not go through the 0 point. If I just plug in 0, 0 squared times negative 2 minus 1. 0 squared is 0 times negative 2 is 0. Minus 1, 0 minus 1 is negative 1, so the order pair will be 0, 1. It's got to be answer A is the only one that will work for the graph.